my fault. You'd think I'd know that by now. Can I just walk through the first pages?
Yes, please.
You all give me 2-3 minutes to do that? I apologize. Okay, sorry about that. Y'all want to go get a cup of coffee or something? Help yourself. Okay, it just hit me that I just now hit the record button. So let me walk through what we just did for anybody listening to this. And I apologize to the people who showed up. They want to take a break or whatever and come back. So we're in section 9.2, and we're talking about how to draw a conclusion about a population from samples. And there are two ways. In method 1, we make a point estimate of the population mean, and it is equal to the sample mean. So for example, if I was in regular class over a 1401 class, and I lined it, they were right there in front of me. So if I could line them up, measure their height, and let's say I got a mean height of 5'8" of just my class, and then I want to know or take an estimate, point estimate, what is the point estimate for the mean height of all UNG students? Well, I basically assume it's identical to the sample I just took, 5 feet 8 inches. It's a very easy question, and the book will lead off a lot of the problems with that. Assume the population has the same mean as the sample. All right, well, can you do this? And obviously you can physically do it. The issue is, when can you do it? And it gives you good information, accurate information. And when can you do it and you get complete crap? Okay, so in method 2, to try to make this more accurate, we form an interval that we think contains the population mean. We can do this subjectively. All right, so what you do is you take a minimum height and a maximum height that you think the mean could be. And you could do this from people you know around the school. And Mr. Augustine thought that the mean could be as low as 5'3" and as high as 6'2". But I ask someone else, and maybe they know different people and they think it's different. So to standardize this, statistically, we put this on a standard statistical basis. And so to do this, we form confidence intervals. The 3 basic ones are 90% confidence, 95% confidence interval, and a 99% confidence interval. The scientific standard for scientific studies is 95%. If you read a study that's using 90%, they're basically trying to cook the books. 95 didn't give them the conclusion they wanted, so they use 90, and voila, they get their conclusion. And if they're using 99, they're really tightening things up. Okay, the next issue is that when you sample, it is incorrect to use the z-table, the bell curve that we've been using. And this is because the sample sizes are too small. So what happens is, someone in the 1920s who was working at a brewery, working on beer, was taking sample sizes off the production line. They explain this on page 407. This guy named William Gossett, you can get on it, working for the Guinness Brewery, I believe it was in Milwaukee. And he was in charge of conducting experiments to identify the best barley variety. And when he was constructing his confidence intervals, and he was using the standard normal table, he did not get accurate results. And so he created his an accurate statistical table or model for it. It's called the student's t-distribution. If you notice, they give you the same kind of z-score formula, an x minus mean divided by standard deviation corrected for sample size. But instead of using a z here, we use a t. All right, it parallels the z table, meaning there are formulas for it that I've never seen. But someone very smart, and by the way, the t table, if you compare it to z, is still normal, but it's much flatter, it's still normal. It's much wider, much flatter. So someone very smart who knows the t formulas punched his way through them, and he very cleverly wrote his answers down in a very cleverly named table, the t table. So to use the t table, the very left column, which is where you're going to find your row, is labeled DF. It got cut off, and I'm going to need to send this around because this is not exactly the same as the one in your book. So I will mail this around because it's got a lot more information here at the top. I think it's much more useful. Okay, to explain what that DF meant, the degrees of freedom, it's easier in a regular class when I actually had 4 objects and can hand them to people. But if I pick 4 objects and give 4 people the freedom to pick any that they want, person 1 can pick any of the 4, he has freedom. Person 2 can pick any of the 3 that are left, he has freedom. Person 3 can pick any of the 2 that are left, he has some freedom. But person 4 is stuck with the whatever's left, no freedom. Which means your degree, each of the 3 people has some degree of freedom, and that's 3 of them, 1 less than the total number of people, the sample size of 4. So your degrees of freedom is your sample size minus 1. And that will give you the row on the t table. Okay, we're basically caught up. I apologize to the people here. Should have hit the record button at the beginning, but we're back and we'll charge into the first homework, page 414. And it's number 7 is our first homework. And it's just exercises in using this t table. So 7a, so off page 414, find t. So area in right tail, 0.10 with 25, and they write it out. Instead of going DF equals 25, they write it out 20 degrees of freedom. They just write the words out. They mean that DF is 25, direct DF. All right, in the word problems, they're going to give you N, a sample size, not the direct DF. Okay, so to find T, we use the T table. This DF25 is our row. Find 25 in the DF column. That'll be our row going across. And we want, okay, I should picture this. We want area in the right tail, 10% of our numbers in the right tail. And this coefficient is T. So we want to find this statistical coefficient, calling it T. So the area in the right, I should have said tail, it says tail, didn't write it. 10% in this right tail with 25 degrees of freedom. The area in one tail, that's what we have here. It doesn't really use left or right, but we've got one tail area that's 0.10. 0.10 is the first column. So we run down that to DF of 25, 1.316. Can you maybe I can get it up there? 1.316. All right. Same meaning as the Z. We'll have 10% of our numbers 1.31 or more, 1.316 standard deviations above the mean. This is still the mean. And in effect, we have the sample size is 26, even though it didn't ask for it or anything. But remember, DF is one less than your sample size. So we were sampling with 26, giving us a degrees of freedom of 25. And our statistical coefficient is 1.316. And we're going to use this in all of the standard kind of formulas you're used to. It's just that in those formulas, instead of being a Z, you're going to use a T. We'll show you that when we get to them. Did that go too fast?
No, it's okay. It's just that in the Z, it is to the left. So for you to find the right, you have to subtract from 1. But on this one, it's just to the right.
No, it turns out that that's a subtle difference. You don't have to do that here. It turns out they don't give you a picture of it, but they took that part out of it. You don't have to worry about subtracting from 1 or anything like that with this. It just, your area in one tail, you're given area in one tail, happen to be the right one. That's one tail. There's your area in one tail. They told you it's 0.10. So I come down that column to my degrees of freedom 25, and presto, there's my number. I'll give you the next trick in the next part B. I think they switch it to left tail. No, it's still right tail. Okay, so in B, 7B, page 414, find T, area in right tail is 0.05. I'll shorten it up. Degrees of freedom is 30. 30 degrees of freedom. You want to see problem in the book? Area in the right tail is 0.05, 30 degrees of freedom, 7B there. All right, I'll picture, very similar picture. Now we've got 5%, 0.05. That's still area in right tail. This is our column. This is our row. So now, area is still area in one tail. 0.05 is the second column over. You see it? And I go down to a DF of 30, 1.697. 30 on, yeah, barely. 1.697 standard deviations. Questions about that? Yeah, you're right. The Z table worked by area to the left always. This works by area in the tails.
Okay, Professor.
Okay, try C. This will show you a trick you've got to do. Find T. So area left of the T value. The T value is 0.01, 1%, with DF equals 18. You want to see this? Area left of the T value is 0.01. In effect, that's left tail. 18 degrees of freedom. So the picture for this see 0.01, and remember there's 0.5 to each side. It's symmetric. You'll have some T value with 0.01. Notice that's still one tail, area in one tail. And your row is 18. So I am going to 0.01 will be the fourth column over. That's still area. That's still just one tail. 0.01's fourth column over. And I'm going to go down to DF of 18. There it is. Easy to get off a row. You see it? 2.552. Like I can't get it all on one screen. There's my DF of 18. Third one down to this group. Fourth column over. 2.552. Now, here is the rub. Remember, zero's in the center. We're on the left side of zero. So is this positive or negative?
Negative.
Yeah, but you see the table won't tell you that. You have to do that manually. The Z table, it did. You could read the Z numbers out and the table would tell you if it's positive or negative. Here it won't. In effect, this is the positive side. This table is the positive side of the curve. And so if your picture says you're on the negative side, you've got to make this negative. That's what they're telling you if you read it in their hint. Hint, use symmetry, if you can see that. Hint, use symmetry. So in effect, the table's almost assuming you're on the right side with 0.01, but it clearly said left, and that's going to make it negative. Questions about that?
I'm good.
Part D, you're going to name your column by confidence. Seven D, page 414. Find T. %, confidence. DF is 20. See this? Critical D value, I'm on a, okay, 7. 90% confidence, 20 degrees of freedom. Now, the actual picture is that there'll be a T here and a T here, and you'll have 90%. This is how you do any confidence interval. The confidence percentage is a center backwards problem out of chapter 7. Any confidence percentage is in the center between two T numbers. Your DF is 20, that's your row. The 90% confidence is this column right here. You can look on your T, that's why the table in the book won't give you this. This table does. Confidence level 90%, that names this column. We're going to go down to row 20. DF is 20. So there we are, row 20. Second column over, 1.725. Now that's this side. There's also this side. But the book doesn't ask for this, and it only reports this as the answer. Questions about this? So it just depends on what you're given. If you're given confidence, you're going to use this top part. If you're given area and one tail, you're going to use the center part to name your column. This problem, they've given you direct DF, but a lot of problems, they give you an N value. Are we ready to jump on to some word problems?
Yes. Yeah.
Okay. I had to really pick and choose among some of these because he really charges into some stuff that really don't want to get into. I think if you look at 27, let me pick one that's with a lot of parts I can go into. Yeah, it just charges in. pH of rain. Why don't we charge it to something like 31? Do you have the assignment in front of y'all? I didn't put it up. But I really picked out some parts. 7, if you look at the assignments for this week, 7, 27 just C, 29, 31, 33 just C, 35 just D out of the book. And then I think I picked out 8 MyLab problems. Okay, why don't we charge into 31? That's got a lot of the parts. This is off page 4, 16, 31. A lot of words to this, but it's about the pH of rain. So this is 12 rain dates in Tucker County, West Virginia. And this is the pH of the rain that they collected. They collected the rain and measured the pH. That suggests some chemistry. If anybody took some chemistry and you know what pH is, it measures the acidity, how acid it is. 7 is neutral, below 7 you're acid, and above 7 you're basic, if you know your basic chemistry. And see how these numbers are way below 7, which suggests that they're getting some acid in their rain, which is an indicator of pollution. You know, maybe near a plant that's putting out some pollution or something. Okay. Determine part A point estimate for the population mean pH. How do you think we're going to do that? Here's the data. There's just 10. I guess I could write it out. 4.58, 5.72 is the way they're listed in the book. 9, 4.75, 5.05, 5.02, 80, 4.74, 77, 4.76, and I ran out of room, so the last two pairs 4.77 and 4.56. Part A, make a point estimate for the population mean pH. You want to take a stab at how we're going to do that? This is my sample. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 12 numbers here. My N is 12.
Yeah, add all and divide by n.
Yeah, that's how you do it by hand. In other words, you need the mean of these numbers. And yeah, you could just add them all up, divide by 12. That's fine. I'm going to punch them in stat mode, just like we did in chapter 3, because we are also in further parts going to need the standard deviation. We're going to need both. We need the mean of the sample of 12 to answer just this question. We don't need standard deviation to answer this question, but further down we do need standard deviation in the other parts. So I'm going to just enter it in stat mode and get both. Stat. Remember how this works. Go up, clear that down. All right, 4.58, 5.72, 9. In other words, they weren't kind to us on this. They didn't give us the mean and standard deviation. Okay, 5.05, 2, 4.8, 4.74. If I'm entering them right, you get to 4.74, 4.77, 4.76. 4.77 and 4.56. All right, well, I hope I've entered that all right. Yeah, 13, I'm in space 13, so it got me 12 numbers. Stat, calc, one variable stats, enter. I'm getting a mean of 4.89. My standard, I'll use an SX there, 0.3194, we'll call it 0.32. SX equals 0.32, that's our standard deviation. And yeah, this is our point estimate. A lot of times they abbreviate it PE for point estimate. The point estimate equals 4.89. Any questions about part A there? Are we ready for part B?
Yes, please.
Okay. Construct 95% confidence interval. For the mean pH in Tucker County. Sorry about that. I don't know if that's startling y'all or not. It's the second time it's happened to me tonight. I don't know what's going on. Okay. I'm going to show, this is the backwards problem. Chapter 7, 7.2. We've got to find our T. Well, remember N was 12. So our degrees of freedom, guess what, is N minus 1, which will be 12 minus 1, which will be 11, and that's our rho. Are we going too fast?
Oh, we're good.
Put back up to 12 numbers. They took 12 dates, so we've got a number for every date. So N was 12. That gives us a degrees of freedom of 11. And our 95%, that's our column. So 90, I'll rewrite it down here. 95% confidence, that's our column. That's third column over, almost direct center there. 95%, come down to row 11. Here's row 11, over to the third column, 2.201. Yeah, our T is 2.201. You don't really have to draw a picture of this, but if you did, you'd have T negative 2.201 and T positive 2.201, and you have 0.95 in the middle. But it's not really necessary. If you can read the information here, realize that's your column, the degrees of freedom is your row there, then you can get your T number directly. Questions about that?
No.
Go ahead.
No, I have none.
Okay. Anybody else have any questions? Really, this was a backwards word problem from chapter 7. Do you remember how we did those?
Yes.
I'll see if you remember the formulas. Chapter 7, remember we have Z was equal to X minus mean divided by standard deviation. Remember, there was no correction for sample size. Correction for sample size. So in 9.2, it's going to be T equals X minus mean divided by standard deviation, but it's corrected for the sample size. All right. We need 2 of these. You're going to have T is negative 2.201 and 1 for positive 2.201. 0.201, you'll have negative 2.201 equals X minus, okay, you gotta, it's on previous sheets, whatever that darn mean was. The mean was 4.89 divided by your standard deviation was 0.3. This is where you need your standard deviation. That's why I went ahead and found it. 0.32, and that's divided by the square root of 12. Use your full N there. I'm going to multiply both sides by this and add the 4.89. I'll multiply by 0.32 divided by the square root of 12 by 0.32 divided by the square root of 12. So I'm going to have negative 2.201 times 0.32 divided by the square root of 12. Until that cancels that, cancels that. This multiplies, and then you're going to add the 4.89, just doing this in one step, and that'll be your left X. This will be the left side of the confidence interval. So I'm going to have negative 2.201 times 0.32 divided by the square root of 12. And add the mean, 4.89. I'm getting 4.6866. Usually we round it to 2 places. We'll call it 4.69. Now, without a lot of writing and everything, number 2, when you have positive, can you tell putting in positive 2.201, I'm going to do exactly the same thing. It's just going to change this to positive. So I'm going to have, I'll write it out, 2.201 times my 0.32 divided by the square root of 12 and add the 4.89. So all I got to do is really call it back and take out that negative. Yeah, 2.201 positive times the same thing and add the 4.89, 5.09. This will be the right side of the confidence interval. All right, I'll collect this. So my answer, this is the way it'll look like in the book. They'll go 4.69, comma 5.09. They usually stick it in parentheses. So there's the left side, and there's the right side. This is my 95% confidence interval. It does not really mean that you're 95% confident that this interval contains your population mean. It really means that 95% of all possible samples will have a mean in this interval. And the same interpretation goes if it's 90% or 99%. Your numbers will change slightly. But if it's 90%, then 90% of all possible samples will have a mean in whatever interval you come up with for 90%. Questions about that?
Don't have any.
Okay, well, I've really, we're at an hour. I don't know how much patience y'all have. Do you want to see any more parts?
I'm good.
Okay, he's good. What they do is in part C, they change this to 99%. And all that does is change, I just wrote that. They change, in part C, they change to 99%. It just changes your t-value. You use the 99% column, and your degrees of freedom is still 11. You get a different t-value. And then you just plug into the backwards formula like I just did. Plug into the backwards formula. Twice, really. Once for the positive t, once for the negative t. Negative t gives you this one, and positive t gives you the upper side. Y'all think you can handle that, or do you want to see it done?
I'm good.
Okay, Ms. Theophan, you still there? You want to see it done, or you think you're good?
I'm good too. Thank you.
Okay, well, sure thing. We'll have 2 more Zooms on Thursday, 12 p.m. and 8 p.m. So, yeah.
Okay, we will try to do some
Okay.
works done.
Sure thing. Then we'll show up and answer any questions you might have. Appreciate y'all coming out tonight.
Thank you. Good evening.
Thank you.
Thank you.
Yeah.